Hey everyone, I'm Gary, the Senior Test Engineer here at the Extreme Computing Test Lab. Every test you're about to see plays a role with one goal, making sure Dell Pro rugged devices excel in the environments you put them in. These rugged devices are not just built to be durable, but also run on Intel Core Ultra processors that deliver powerful performance, enable AI use cases, and increase end-user productivity. Combine that with Verizon's 5G network, access to data is as simple as turning on your device. So what we do in this lab is test to fail, so that when you take these devices out in the field, you can count on them to always perform. Let's get started. First up is drop testing. Our transit drop machine drops devices from up to 3 to 6 feet, sometimes 8, at every angle, and we use high-speed video to watch how they behave. We're not here trying to meet specs. We're here to break them. We drop on concrete and steel, not just plywood, so you can get devices that survives more than just the minimum. Sometimes we freeze devices to -60°F before dropping them, simulating Arctic forklift operators or food industry workers moving in and out of freezers. A lot of our deployments go inside vehicles, so there's a lot of vibration. We mimic real-world abuse by shaking devices in pneumatic shaker tables. By finding and fixing weaknesses here, we build in the robustness you need for mission-critical work. In our thermal chambers, devices are tested from -20°F all the way up to 145°F, because inside a vehicle, on a hot summer day, you can easily reach up to those temperatures. We do thermal shock cycles from -60°F all the way up to 160°F to make sure different materials don't tear each other apart. We also simulate 95 to 100% humidity so your devices keep working no matter the climate. When you set your device down, it's almost never gentle. You toss it on your desk, in the back of a truck, and we test for that. Here, robot arms perform 10,000 short drops from 6 to 8 inches. These micro drops reveal fatigue failures, not just brute force impacts, so we know how the device will hold up over time. For users on the go, they are constantly opening and closing their devices. Automated machines open and close the lid up to 150,000 cycles, simulating years of heavy use. We use dust chambers with pulverized talcum powder to test for our IP and dust resistance. During the test, we pull a vacuum on the device and try to suck dust through its seals. At the end of the test, any speck of dust that is able to get in is an automatic fail. In our rain chambers, it simulates everything from light misty rain to a heavy downpour. We even take these devices and spray them down with powerful jets of water just in case a system ever needs to be washed out. Salt fog chambers simulate coastal environments, testing for corrosion and material degradation. If you expose a non-rugged unit for 4 days, you'll start to see galvanic corrosion, so we make sure our rugged devices can handle it. We expose these devices to oils, gases, bleach, and other chemicals because we don't want our product to degrade over time and affect functionality. We test for resistance to harsh chemicals so users can clean devices with degreasers and disinfectants without worry. There are many other tests that we do in this lab, including connector robustness tests, tumble tests, and electrostatic discharge tests. Thanks for exploring the Extreme Computing Test Lab. Everything we do is to ensure your Dell Pro rugged device is connected, secure, and built to thrive in the most extreme environments.